everyone, welcome to my YouTube channel. This channel is about mathematics. Okay, allow me to introduce myself. My name is Kadek Rima Suryani from class 2 IKI with study number 22131010007 from the Mathematics Study Programs at Ganesha University of Education. Okay, without lingering long, let's discuss the materials. Enjoy these videos! Okay, the materials that will be discussed today is a set. What do you think when you hear the word set? You must be familiar with the word sets. Okay, I will give the examples of sets. This is example of a set. Indonesia has 34 provinces covering East Java, Central Java, West Java, and 31 other provinces, meaning that Indonesia is a set that has a member as Java, Central Java, West Java, and 31 other provinces. The topic to be discussed in the materials about, namely, definitions of sets, some basic concept in the sets, and the last is set operations. For the examples I give, can you imagine what a set is or what definitions of sets? In mathematics, a set is a basic concept used to group similar or related objects. In mathematics, a set is a collection of objects called elements, which can be numbers, letters, or other objects. Example of the sets. In the food associations, a set is a rice, meat, vegetable, fruit, bread. The set is contain different types of food that we can encounter every day. And another examples, in mathematics, the sets of positive integers. The set is 1, 2, 3, 4, and so on positive integers. This set contains all positive integers, starting from number 1 onwards. Okay, for the next material is some basic concept in the set. The some basic number 1 is elements. What is elements? An elements is objects that belongs to a set. For example, in the set's number, curly braces 1, 2, 3, the numbers is 1, 2, and 3 are the elements. You get it? Okay, for the next is not element of the set. If an object belongs to a set, it's referred to as a members of the set. If not, then it is called not a members of the set. For example, is the numbers 2 is a members of a set of even numbers, while the 3 is not a members of it. Okay, from the next is set notations. The set can be expressed by using capital letters. For example, is A, B, C, so on, and the capital letters. And then while the members of a set are represented by the lowercase letters A, B, C, and so on, lowercase letters. For the method defining of a set, in number 1 is the rows of or a list methods. That is by writing the members of the sets in curly braces. For example, P is equal to curly braces 1, 2, 3. And number 2 is the rule method. The rule methods or formula is to express the properties specified by the members of the set. For example, is Q is equal to the set primes numbers less than 10. And method number 3 is set performing notation methods. For example, is P curly braces X such that X is the days in a week. For the last method is the Venn diagram methods. The rule for creating a diagram fence are as follow. Number one is the universal set is represented by written set and is given the letters A's in the upper left corner. For the example is in the slides. And number two is the set is represented by closed curve and is named with a capital letter. For example is B in this. And number three is the members of the set are represented by the dots. Okay, for the next concept is empty sets. What is empty? What is empty sets? An empty set is a set that has no elements. The notation for empty set is curly braces or empty. This is in the slides. For example, is B is the set's names of the day beginnings with the letters X. Then B is empty sets or B in these notations. Okay, for the next is universal sets. A universal set is a set that contains all relevant elements in a given context. The universal set is usually denoted by the letter X. For the examples, the sets of integer universe in the sets of all positive, negative, and zero integers. Then the notation is S is equal curly braces 0, -1, -3, minus, and so on in the negatives. And then the 1, 2, 3, so on, and the positive integers. Okay, for the next is finite sets. A finite set is consisting of a finite number of elements that can be counted or described. In a finite set, the numbers of elements in the set has a certain limit and can be counted or example curly. For example is of a finite set, the set of positive integers up to 10 is equal to curly braces 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is an examples. The elements of the set of positive integers are limited to 10 and can be spatially counted. For the next is finite sets. A finite set is a set that has unlimited numbers of elements or cannot be spatially counted. In an infinity set, the elements of the set have no defined borders and cannot be completely numbers or described. For example, is the set of positive integers, curly braces 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on a positive integer. This is example that the set of positive integer has no finite and the elements cannot be spatially counted because they can be added. Okay, for the next is operations of the sets. The operation number one is similarities of the sets. Similarities of two sets, A and B, are said to be equal or identical, A equal B, if only they have same element. For example, is set A is equal to curly brace 12, 10, and 11. And set B is equal to curly braces 10, 11, and 12. That it is said A equal B. And on the slide, there is an example of Venn diagram according to this example where member A, namely 12, 10, and 11 are also member of B, namely 10, 11, and 12. And the next is equivalency sets. Two sets A and B are said to be equivalent only if the numbers of members of the two sets is the same, even if the elements are not the same. For example, is set A curly braces 1, 2, 3, and B is equal to X, Y, and Z. Then is example, they have the same numbers of element A equivalency B because NA and NB is equal to 3. This is example equivalency sets. And for the next is subset. Set A said to be a subset of set B if every element present in the set A is also present in set B. The mathematical notation for a subset is, or in the slide, is subsets notations. For example, is set A curly braces 5, 6, 7, 8, 9. For set B is 5, 6, 7. Then A subset of B. For example, its diagram friends is A and the B. Okay, for the next is power set. A power set is a set whose all members are a collection of subsets. The power set can be expressed by 2 to the power of A or PA. For example, if A curly braces 1, 2, then 2 to the powers of A is equal to curly braces 1, curly braces 2, and curly braces 1 and 2. Okay, for the next is the intersection of two sets, A and B, denoted by A intersecting of B. Is the set that contains all the elements present A and B simultaneously. In the intersections, only the elements that are in the both set will be a part of the result of sets. In other words, slide take the same or similar element between the sets. For example, is A equal to 7, 9, 8, 10. For set B is equal curly brace 6, 7, and 9. Then the intersections of set A and B intersections will produce a new conciting the same elements in the two sets, namely curly braces 7s and 9s. For the last operations of assets in independence of assets, two sets are said to be mutually independent if they do have the same element. That's it. There are no elements present in either of the sets. Independent set can be written for the slide is A independence of B. For example, is set A equal to curly braces 6, 7, 9, and 8. And set B is equal to curly braces F, H, I, G. And then the A independence of a set because each of this set does not have the same element, then set A and B are independent. Okay, that was a discussion about the set. If there is some things you don't understand, you can contact me on Instagram or can you comment in the comments columns. Don't forget to subscribe to my channels. Okay, see you in the next video. Bye!